Hey, we're back. We're doing our scientific method notes now. We're doing fill-ins, so let's go ahead and get started. Let's learn a bit about the scientific method. First of all, what is scientific inquiry? Well, it's simply ways that scientists study the natural world, and from there they propose explanations based on evidence they gather. Well, first of all, inquiry. Sometimes maybe your parents were selling something and somebody called on the phone and you picked it up and said hello. And they said, yes, I'm calling to inquire about the car that you have for sale. Well, inquire basically means to collect or ask or gather information, more information. And that's what we're doing here in science. When we're using scientific inquiry, we're gathering more information and we're trying to come up with an explanation based on the evidence that we've seen. So that's basically what it is. That's going to lead us into the scientific method, because the scientific method is a series of steps that's going to help us solve and answer those problems or questions that we come up with from our scientific inquiry. So what is the scientific method? It's simply a series of steps that scientists use to answer questions or to solve problems. And in our book, there are 6 main steps that we're going to learn about. The first thing that you do is you come up with a question that you're obviously curious about. From that question, you're going to form a hypothesis. Then you're going to test the hypothesis, analyze your data, draw some conclusions, and then communicate your results with others. Now, there's a nice mnemonic device, a way to help you remember these 6 steps, because this could get confusing. I always teach students, remember this phrase: question Fred today after drawing class. Q stands for question, step 1. F in Fred stands for form hypothesis. T in today stands for test hypothesis. A in after stands for analyze your data. D in drawing stands for draw conclusions. And then finally, C in class stands for communicate results. Please remember and memorize this phrase. It will help you remember these 6 steps that you're going to be tested on. So question Fred today after drawing class. There's our 6 steps. Alright, so let's start with the first step. Let's kind of talk about each step and then we'll go from there. So in our first step, the question, we simply pose a question from an observation. We talked about an observation, something where we use our senses to gather information. So my question is, do 6th graders prefer pepperoni or cheese pizza? That's my question. From there, I want to form a hypothesis. What is a hypothesis, you ask? It is a possible answer to your scientific question. It's not a fact. It hasn't been proven true. It's just a possible answer. So hypotheses must be 3 things. Number 1, it has to be an if-then statement. So if I do this, then this is what will happen. Number 2, it has to be testable. If I can't test it, it's a bad hypothesis. Number 3, it has to be a possible answer to this question that you've come up with in the beginning, our previous slide. So, what would be a good hypothesis? Well, here's one that I gave you. If, remember, it's got to be an if-then statement, so it always starts off with if. If 6th graders are given a slice of pepperoni and a slice of cheese pizza, then, there's the then part, 6th graders will prefer pepperoni pizza. Number 1, is it an if-then statement? Yes, because there's the if and there's the then. Is it testable? Can I give a slice of pizza and figure out whether or not those 6th graders are going to prefer the pepperoni over cheese? Sure. Finally, is it a possible answer to my original question of, do 6th graders prefer pepperoni or cheese pizza? Sure, it's a possible answer to my question. So that's what a hypothesis is, a possible answer to your question. Step 3 is simply testing the hypothesis. This is where you have your experiment, and this includes all your materials that you're going to use, your step-by-step procedures, step 1, step 2, step 3, step 4, step 5, any data charts and tables and observations. This is all part of testing the hypothesis. Step 4 is analyzing our results. Data are facts that's gathered through observations. That's all the stuff that we've collected through our senses. Analyze means to simply look over things, looking for the patterns if we notice anything. Also, when we analyze, we make pictures or graphs with the data that we've collected so we can observe it and identify some trends quicker. So for example, analysis is graphing your results. This down here would be an example of how you would analyze your data. You're going to have it all done up in some type of graph, whether it's a pie graph, a bar graph, it doesn't matter. Whatever best is to show your information. Step 5, drawing conclusions. It's basically a summary of what you've just learned from your experiment. This is where you're going to include what errors did you find? Was there any unknown variables that we came across that we didn't even think could have thrown our results off and made them inconclusive? You examine your results to see if it supports your hypothesis. If it doesn't, then you may have to go back, fix the problems you found in your experiment, and experiment again. You retest it then. So here would be an example conclusion that you could write. You always start off with "in conclusion" or "I learned." So in conclusion, I proved my hypothesis correct. My data and graphs show that the 6th graders preferred pepperoni over cheese. 125 students preferred the pepperoni, while 17 students preferred cheese topping. Here's where I actually used my actual data to support that. If I did this experiment again, I would change the pizza company. An unknown variable that I did not consider was whether students had just eaten pizza at lunch. Could that have affected things? Sure, if they weren't hungry, I don't want any pizza, thanks, or I don't really care. I ate something at lunch I didn't care for and it reminded me of the pepperoni. Those types of things could affect your results. So this would be considered a very good conclusion for our class. Step 6 is where we communicate our results. This is where we share ideas with others. We describe what we did, so if somebody else wants to try it and see if they get the same results, they can. How can we communicate? We can do it through meetings, scientific journals, internet. Those are ways to communicate the results. Here's some students from last year demonstrating the scientific method, all 6 steps. Let's see if you can identify the 6 steps.
Can't I open my locker?
I know how you can open your locker with this scientific method.
What's the scientific method?
It's the method for all experiments. You need a question, then you form your hypothesis, then you test your hypothesis, then you analyze your data, then you draw conclusions, and then you communicate your results.
Well, that sounds cool. Let's try it. So my question could be, can I open my locker with any combination? I think that's a good question, don't you, Megan?
Yes, I do.
Okay, now for a hypothesis. The hypothesis has to be an if-then statement, testable, and a possible answer to your question. So, my hypothesis could be, if I try any combination on my locker, then it will open. Let's test it out. Didn't work either. The third one did work. So, that's analyzing your data. Now for a conclusion.
So, in conclusion, Jordan disproved his hypothesis. His locker won't open with any combination. It'll only open with one.
Now to communicate results.
All right, great job to those students last year. Right there, they demonstrated all 6 steps with just a simple question that they had about whether the locker would open with multiple combinations. All right, let's talk about hypothesis versus theory versus law, and then we're done. We already said a hypothesis is a possible answer to our scientific question. It's not a fact, and it's usually the result of just one person or a very small group of people have a thought or an idea. Kind of like what you saw there with our 2 students. It was just a small group that had an idea that they wanted to test. That's typically a hypothesis. A theory, though, is a well-tested and widely accepted idea by many, meaning many people have gone through, tested it, and it's well supported with lots of evidence, and it's thought to be the best possible explanation for what's happening. Theories are used to explain why something happens. So theories explain why something happens. It could be proven incorrect, though. Some more famous theories is the modern-day cell theory, the theory of plate tectonics, how our different plates that the continents float on kind of drift around. And then, of course, one of the most famous theories that has been proven incorrect is the theory of spontaneous generation, which basically says that living things come from non-living things. So basically, fish come from mud, maggots come from rotting meat, and my favorite analogy is that dirty laundry plus corn, wait 21 days, and poof, you get mice. That was the idea behind spontaneous generation. But they proved that incorrect several hundred years ago. So, thank goodness. So that's what a theory is, trying to explain why something happens. Finally, a law. A law describes what will happen. It is what scientists expect to happen every single time under certain conditions. Law is typically explained using mathematical equations, such as Newton's laws of motion or Newton's law of universal gravitation, which this is his equation. We don't need to know that, so don't panic and freak out. No, I'm just giving this as an example. But typically laws are used and expressed with mathematical equations, and they will describe what will happen every single time, like laws of motion. We know this is what's going to happen. Objects at rest will stay at rest. Objects in motion will stay in motion unless acted upon by an unbalanced force. Okay, that's the law. So there's a difference between hypothesis, theory, and law. Finally, we're to the end of our notes. This is where you write your final question. Write down at least one question at the bottom of your notes that you still have or you're still a little unsure about regarding the scientific method, the steps of the scientific method, what a hypothesis is, inquiry, law versus theory, and then come to class, be ready to ask your question, and I'm there to answer it. All right, we're done. I'll see ya.